Mathieu Sozo, Adrien Galinette, developer Coq.
Coordinator.
Yes, coordinator.
And you are usually located in Nantes.
Yeah, usually in Nantes.
And you're the author of equation.
And the author of equations, which I'm going to talk about.
Maxime Denes. I work in Sophia Antipolis. I'm part of the Coq development team. And I work as an engineer in the Coq consortium.
Romain Tettler, I'm new here, so hi. And I work in Sophia Antipolis with mainly with Maxime and Enrico on VS Coq too.
Hello, I'm Yves Berthaud. I'm based in Sophia Antipolis. I do mostly political stuff, so trying to find money and helping to set roadmaps. Did you hear me?
What was that?
Did you hear me?
Yes.
Okay.
Only one mic?
No, there's one here.
I don't know.
It's different. It's a different system.
Qui suffit.
Okay. Hello, I'm Enrico Tassi. I'm based in Nice, Sophia Antipolis as well. And, I'm a Coq developer.
The author of Coq NLP.
Yeah, okay. Today my main focus is on this extension language called LP.
Hello, I'm Theo Zimmerman. I'm an assistant professor at Telecom Paris. I'm mostly in charge of documentation and managing contributions in Coq, and I'm the release manager for 8.17.
Hello, I'm Pierre-Marie Pedro from Nantes, area researcher. I do stuff.
LTAC 2.
LTAC 2, and performance, and more.
Renting.
Renting.
Hello, I'm Gaëtan Gilbert. I'm an engineer. I work in Nantes. I also work with Maxime in the Coq consortium. I do various work on Coq for engineering work.
And recently you have been concentrating on?
I've tried to work on LTAC 2 some, and recently I've been fixing parser bugs.
Okay.
Hello, I'm Kenji Maya. I'm also based in Nantes. For now, I haven't been working much on Coq, but around Coq, let's say. And it's been some time I'm trying to get involved.
Okay.
Awesome. My name is TJ. I'm a student at the University of Kansas, and I currently am using Coq as a part of my, PhD work, and interested in what y'all are doing.
Okay. And Hugo and Emilio should arrive along with Ali at some point. I don't know if they come back or if they have a problem coming.
So Ali had the first slot, right?
Yeah, but we are switching.
Yeah,
so
okay.
Ali will come for sure. But I have no news about Hugo and Emilio yet. Which is strange.
Emilio texted me 30 minutes ago, so
That
should be alive. But
okay.
doesn't he live near?
Yeah. Yeah. We'll see. I'm gonna start anyway. Talking about equations. Share. This. Ta-da. Okay. This is just a ChatGPT rendering of Coq developer.
ChatGPT, really?
It's, yeah.
Not chat,
Well, it's not ChatGPT. It's
Midjourney.
Yeah.
What do you mean, Mitchell?
It's an AI.
It makes images from whatever prompt you give.
What did you give?
Coq developer.
Coq developer.
Yeah. Pretty mean.
Something worse, but yeah.
I was about to say that, but let's not. Okay. So I'm gonna talk about a topic that comes from time to time. That is how to move away from function and integrate equations in Coq. And I'm going to focus on a problem I found, which is the treatment of Latins. So the motivation is that we'd like to move away from function, and that requires a translation basically from the usual way we write programs in Coq, using match and fixed points to equations, which uses dependent pattern matching. So it's a different way to present pattern matching, where you write your clauses and there's a matching algorithm, and that it handles dependency correctly, which gives a kind of different semantics to pattern matching. There's a question of how do we use well-founded recursion. So in equations we use accessibility and just well-foundedness. Function is based on an iterating construction. I think they are equally expressive, but actually we never really thought about that. We thought it was trivial, but I'm not sure it's so trivial.
Sorry, I was distracted. Can you repeat the question?
Are the two ways to handle recursion equally expressive? So equations use just well-foundedness, but in function you use this iterator.
Maybe you can.
There's a camera behind you.
And I'm wondering if they are equally expressive.
You can try to squeeze.
I think the iterator is only to help making the equations, so the well-foundedness is
Easier to derive?
Yeah. The well-foundedness is absolutely needed.
Yeah, there is well-foundedness for sure in those cases. But
yeah.
So I think they're the same.
Yeah.
I mean, you should.
I think it would be the same in the end. Maybe the reason, my reasoning is that I don't know what equations does, but we don't go over the power of well-foundedness in function.
Yeah. Okay. Good. And then in most Coq definitions, you will use let bindings, but they are not directly supported by equations or the usual splitting tree construction that you have in dependent pattern matching. So for example, in Agda, they are compiled away, they are just substituted, the Latins. One way to support them would be to translate lets to where clauses, but where clauses correspond basically to subprograms, which would give you a different elimination principle for the function. You would need to give a motive for every let in your program, which does not really make sense. So we'll need native support for let bindings. Okay. So I'm gonna give a short run through dependent pattern matching, how it's implemented with equations, and then focus on Latins. So you probably all know about pattern matching with dependent types, which was introduced by Coq in 1992. And basically, the notation of dependent pattern matching is different from what you have in Coq, in that you write only clauses for the instances of the family you are inducting on or destructing that are relevant. So here I have a typical example of a vector. I write the tail function, it takes a vector of size n+1, so I only need to consider the case vcons because v-nil is of size 0 and 0 is different from successor. Okay. And what happens when I do that is that I really refine the v variable into a vcons. So it's not possible in the right-hand side here to mention v, right? I can just mention the septum. So there are ways, of course, to add a let binding, exactly, to say that I want v to be these vcons. But you really refine variables when you do pattern match, when you split, which is not the case in Coq in general. When you do a match on v, you will have the case for vcons, but you will still have access to the old v variable. So for internal pattern matchings, in 2004, McBride and McKenna introduced, in the view from the left, a with construct, which allows to add new variables on which you want to pattern match. So with equal nm here, I'm saying, oh, I want to pattern match on the result of this call. So I have a new pattern. Here I had 2 patterns at the initial problem. Now I have 3 patterns, and I can recursively do pattern matching on all of them. There's a subtlety that you need to introduce the notion of inaccessible patterns. So here, this n is inaccessible, meaning that it's determined from the other patterns in this set of patterns. So if I have x or n, whether be successor of some n prime, and the proof is that successor of n prime is equal to successor of m, and n prime is equal to m. Then I can match with eqREFL, and I basically apply a substitution to my patterns, and this means that this variable is uniquely determined to be n. Okay, this was adopted in Agda 2 and epigram and equations as well.
So the terminology of inaccessible pattern is bizarre. Why is it in what way is that inaccessible?
It means it's not a binding pattern. So here you could have an arbitrary term. So the structure of patterns is constructors and variables. Okay. But in inaccessible patterns, you can also have arbitrary terms. Whereas the structure here has to be constructors or variables. Mm-hmm. And you're not matching on them. They are more determined by the rest of the patterns.
So at this place,
they don't give you information.
You wrote an end as a way to document. That
but you could write underscore.
But you could have put an underscore.
Yeah.
And the end that you put, does it mean there is a check that is done?
Yeah.
That it is really the same thing?
Yeah. Actually, every clause in equations program has to type check. So this can type check, but there is no way that something else than n would type check here.
Isn't it rather an unbinding pattern rather than an inaccessible pattern?
Yeah,
non-binding, you could say, but it's not a pattern; it's an arbitrary term. So here it's a variable, but it's
you wrote inaccessible pattern, so I meant maybe it's non-binding, and you said, but it's not a pattern.
It injects
so this, the question mark of a term is a pattern.
Okay,
but this is really not a pattern.
But inaccessible, I mean, in this context, for beginners, it makes us think of.
For documentation, it would be nice to change this to be.
So in Agda, they don't call it inaccessible; they call it something dot patterns because they put a dot in front. But that's another name. Anyway, it's just terminology. So how does it work? You get when you have a definition, you have a set of clauses. You have always a prototype, so the type of the function you want to define. You can pattern match only, of course, on inductive values. And what you do is that you basically match the list of patterns here with the current problem, which at the beginning is just the variables. So you have a unification algorithm that can succeed with a substitution, fail, or get stuck because some variable is not refined enough and we need to split on it. It has standard first match semantics, and we can refine the initial variables to match the patterns and check for exhaustiveness and so on. And the addition of dependent pattern matching is that not only we unify the patterns that appear in the terms, but also the types that are implied by the constructor applied to some variables are unified first. And we use the usual rules of unification for constructors, no confusion, so disjoint, injective. And we have the theory of equality as well. So how do we compile that? So that's been introduced by Gogan, McBride, and McKenna. When we have this unification, we can actually witness it by a proof term that manipulates equalities. So it's a bit complicated equalities, it's dependent equalities in sigma types. But basically, if you unify T and U and you get a substitution sigma, then you can get from a proof of T equals U kind of verification of the substitution. Yeah. And when we eliminate a variable, what we do is we generalize it. So here I have I of x is of type I of t. So t might be arbitrary terms here. We generalize it with a fresh variable y of type y of u, where u's are only variables. We add an equality between sigma types to say that the new variables are equal to the old indices. We eliminate it. We can apply the elimination without losing any information in that case because a fully general value of the inductive type. And then we get this equality and we apply a simplification that basically does unification here to solve that equality, to simplify that equality. And the main structure that's used in the implementation is context maps, which are basically substitutions. So here I have in gamma a substitution sigma that gives witnesses for all the variables in delta. So basically sigma is of size of delta and well typed in gamma. So it's well typed with respect to the substitution itself. So it's a dependent substitution if you want. And we start with the identity substitution on the binding the variables in the prototype of our function. And we will gradually refine it. So if we have this problem here, I have some variables and then a natural number. This substitution sigma and x give me an instance of this context. When I split x, I get two new context maps. One where the natural number is 0 and one where it's successor of n for a new natural number here. And basically, at the leaves of programs, we live in this context, in the context on the left. And the type that we must inhabit is the initial type where we substitute with this substitution here. So we basically maintain this context map to tell us where we are in the refinement. And we have the clauses that tell us how should we assign right-hand sides to each pattern match after splitting a variable. So if we are in this situation, we will look for user clauses that match with 0 or successor and continue from there. So originally this meant that all the variables that appear in sigma and the current substitution should appear in the clauses and you should match them at each time. But this is a bit impractical if you have nested recursive definitions because you would need to rebind the function that is in your context at each clause. So equations introduces hidden pattern variables that allow you to not have to rebind and mention the variable name in the clause definition. So when we are matching, we just keep these hidden variables there canonically in the substitution. So recursive function prototypes are passed that way. And what happens?
The sigma in Latin letters is the same as the sigma up there.
The sigma in Latin letters.
At the end of the line, after skipping hidden pattern, to write in sigma.
Ah, right, yes, absolutely. So we skip this pattern. We don't have to match it. You don't have to mention it each time. So when you have a recursive function prototype, typically when you do well-founded recursion, there is a dependency between the initial argument of the function and the type of the recursive definition. I mean, the recursive prototype. It gets refined when you pattern match on the argument. So actually, the function prototype might move in gamma here. Because you need to generalize over it. You apply substitution when you do unification, so it can change. And then, based on this context map, when we have a splitting tree, so we have this splittings of variables we need to pattern match on. We get context maps, and we can compose them to get to the context map corresponding to the leaf of a program. So as I said before, we can compute the return type based on this substitution to find the actual return type of a leaf of the program. All right, and this also works with hidden variables, no problem. So if we want to have kind of native support for Latin, so first the Latins in CIC are dependent. So we have to be careful to not confuse them with ML-like LEDs. They are really transparent LED bindings. So if you mention a LED bound variable anywhere, it's really the same as mentioning the body. They are not abstract. Okay, you have reduction rules that allow you to unfold the body everywhere.
So it's more because we don't know how to do better.
The question. That's a question for the discussion, I think. But in practice, when you program, you don't always use the dependency. If you think of ML-like LED bindings, you're going to use them for abbreviations and sharing, but not necessarily for dependent typing. And that introduces a kind of a mismatch with the way equations treat these context maps. So here I'm giving an examples of writing an equations function. We don't care about the argument here. I'm LED binding two things, and then I'm doing an internal pattern matching on one of the variables, and I'm returning things that might mention the LED bound variables. So the first question was, how can we model them in context maps? Well, we have to carry the LED bindings around, because the body of the list of the program might mention the LED bindings. So that's not too hard. We can just extend the context to have LED bindings, and we carry them around in our substitution. But of course, same problem as with recursive function prototypes. We don't want to the users to have to repattern on these variables. So we use hidden patterns to hide the LED bindings. And what happens with dependent pattern matching is that the body here, T, and the type, of course, can get refined by pattern matching. So if T mentions some variable Y and you split on Y, then the body of T will be refined to, for example, 0 and successor. So in each in different branches of the pattern matching that comes below, you might have actually different bodies in the LED bindings. So this introduces some duplication of the LED binding. Whereas if you had a LED binding like this in a usual Coq definition, then it has a single place, right, the point of introduction, and it doesn't get refined in later branches. So basically, when the natural way to introduce them in equations is to use a convoy pattern to regenerate them each time you eliminate something that appears in the body or the type of the LED binding. But of course, this will introduce some duplication. You will have branches where you must actually introduce the LED binding at different places in the programs, and it would be natural. So you can have duplication if you use the LED binding before refinement and after refinement. You actually have two LEDs that appear in the compiler. So it's different from what you would naturally expect. So there are two solutions. We can accept it. The compiler term has the same convertibility behavior than what is the expected operational semantics of your program. Just that it actually duplicates computations because you might have multiple times the same LED binding. Or you could also introduce non-dependent LEDs that would then behave like abstractions. So instead of compiling them to a LED binding, they would basically be compiled to a lambda. And then you would keep sharing. But then you have a problem when you want to reason on the program because you've hidden the body, so you cannot reason on the shape of the body of your LED later. But it does keep the intuitive behavior of LEDs, and you can still use the inspect idiom that we use with Wiz to remember when we pattern match that there was an equality between the object we matched on and each pattern, to remember the body of a LED was something. That's one way out of this problem. This would keep a single point where you introduce the LED, but you would be able to remember in the obligations via typing what was the body, and you could reason on that. Because if you don't use inspect, then in the elimination principles, it's a bit strange with this abstraction because you just have a new variable of type nat and you don't remember of which. I mean, what is the body? You cannot really reason about it when you eliminate. So we could support both as well. But there is a trade-off here between expressivity and reasoning power and what is faithful to the intuitive idea that when you write let y here, you expect it to be bound at this point and not just here because the variable is only used here, or twice because it's pattern match here, and then you do something and then you use y again. So you might have 2 points where y has been assigned. So what do we do?
Why did we want that in the first place?
Let's.
Yeah. I mean, you could
Because
just
so in I think it's a limitation of equations. So I know that you cannot have subcomputations. I mean, you can have with, but then you need to inline all your subcomputations. Whereas here you have a nice organizing principle of let's to say, oh, I'm going to pattern match, but first I need to do this and that function call. It's quite natural actually to use let's when you program, right?
how it will behave. So assuming we pick any of the two behaviors,
Mm.
how will it behave with regard to extraction, for instance? Because in one case you just duplicate.
You will duplicate. In many cases, you won't use the same lead binding twice on the same code path. So you will actually only get one binding, but it might come at a later place because it was refined somehow. And with the abstraction one, then you have just one binding for each lead.
Yeah, you're just like committed
Yeah.
cuts and.
Yeah.
So, the reason I am entering needs for equations regularly is because on Stack Overflow you get to cater for people who are coming from a programming perspective, and they are bothered by the fact that the fixed point construction is limited with respect to just structural recursion. And so they want to have a nice access, readable access to well-founded induction. And right now, function or Coq equation is the solution. And if you start using the Coq equation approach, they will this kind of public. For them, the expected behavior of the lead binding contains a strong attachment to the complexity of the obtained algorithm. So you want to avoid moving lead bindings around if possible. I hope this would be this could be accommodated. Like you could define your algorithm saying you try to maintain the non-moving property of lead binding as long as possible. And if not, you have to revert to the other solution. So maybe that's one of the techniques you were mentioning.
So it's possible that by using commutative cuts, you could recover from the compiled term, and you could try to hoist lead bindings as at the top, or as.
And with respect to extraction, it may be necessary that your language is annotated to express that the lead was at a given place, so that when the code is extracted, you try to put it back at the right place. So that annotate it in such a way that you don't lose information of where it was.
There is a strong mismatch in that case between the semantics of the target language like OCaml and the one of Coq. The binding in Coq are really not things that they are not called by evaluated binders.
But you can do your best. I mean, the non-dependent case, you should be able to hoist them.
It's compatible, but we don't.
At their original place. The thing is that it can be an optimization. So here I think what happens currently is that Z is not bound. Maybe it is. Z is not bound for this branch. So in the code path that goes to Y here, Z is not bound, and it becomes bound only in this branch. So the natural path that the equation takes is to put the let at the later latest place as possible.
So if we want to do call by value, so if that's the thing we have in mind, why don't we just box everything? Like we have we instead of viewing code, well, essentially as you would do a real commutative code, like you just say that let binding is just actually compiled to pattern matching over a box type. And it's compiled as a match. So you just to do a let binding, you just have to write the match directly in equations. That would correspond to the. That wouldn't be a let binding of Coq. I think that would exactly correspond to the one where you
To the abstraction one.
Abstraction one, yeah. But it's compatible with the equation. Like you don't have anything to do in equations. Like it's just a syntactic sugar where you match on box.
Yes. And it would be removed by extraction.
It would be, yeah, you just say, please unfold, this is a singleton constructor.
Yeah.
But in
Maxime doesn't seem to agree.
Well, you are giving importance to the semantics of Coq, which is not called by value by default.
Which is not called by value, period.
Yeah.
It depends how you. I mean, I guess it's kind of unspecified. No?
It's called by name.
Or it's specified as called by name.
It is specified
But
as called by name.
somehow we also have targets that we expect to be called by value, like attraction, also CBV,
Yes,
things like that.
indeed.
So it's a bit strange that when you target such a backend, you don't get the expected semantics for called by value.
Yep.
I'd like to keep it.
I think I would have liked to say, well, it's not specified, and
I don't care.
and I teach as if it was CBV, and so that
Yeah, I mean,
it is an easy path for people
coming
to
from
onboard
programming
people.
languages, yeah.
But you are putting me in a yeah.
Well, if we cannot observe time, then maybe it doesn't matter.
No, you can't be called by value because you have strong reduction, so you need to substitute arbitrary terms and arbitrary stuff.
So the problem with this abstract lets is it the same as with actually. So there's also a design question here. Should there be kind of a mode of equations where every let and with also automatically has an inspect so that you keep an equality? That was something
That's what I was suggesting.
Eve was suggesting.
You could have a notation for that.
Or just a notation, yeah.
An attribute? Do we have a substring level attribute?
Yep.
Alright, so you would have the attributes
But
everywhere.
it makes sense to have both, right? You would like, I mean, I understand that the default might be not the one you hope for, but when you start
Yeah, for beginners, for sure, you want them to have inspect all the time, otherwise they're always lost with the first definition they make. Oh, I don't know. I cannot prove my function.
Why can't I prove my function?
Yeah.
It's more like an optimization, to not have.
to not have.
Yeah, it's more bare bones. Yeah. So maybe an expert attribute, which removes this.
But you want the attribute on the whole equation?
I think on the whole definition would be sufficient. Yeah. Just disable the introduction of inspect. And then we can have the abstract let, so they have the expected semantics for extraction, but they introduce the thing, they introduce an equality, so you keep the type information and you don't lose any expressivity for proving something is terminating.
Yeah.
But Pierre-Marie might be.
And that corresponds to what function does, right?
Yeah. Well, when we designed function, we did not think too much about the semantics of Coq. In fact, we did.
No, you are
No,
thinking
but
about programs.
we were really trying to cater for programmers and make them as comfortable as possible when coming from OCaml programming. And then if we push too much in this direction, then it might be a problem that it biases the perception that newcomers have of Coq, and it puts the shock of discovery later, but maybe at the wrong place.
Like people like Jason Gross who do discover that writing eliminators in call by value is not a good idea. Interesting. Like you can see experts who are surprised.
Yeah.
Like very late in the process.
Yeah. I wouldn't worry that much.
Okay. No, but you know where I stand. I really like to have a smooth path from coming from call by value functional programming to expertise in code.
Yeah.
And
What about coming from Haskell?
that's the problem. We basically are somehow a community where we are somehow
It doesn't.
tainted by the.
They don't have a problem.
Practice.
Whatever interpretation we use, however we compile it, observationally is going to be the same. So
Not up to like on ground terms, yes, but the equations satisfied definitionally will not be the same if you expose the term, right?
yes, because lets are transparent, so there's nothing that can distinguish where you put the let, actually. Except if you do syntactic pattern matching on the term, but
I mean, LTAG,
that's
stuff like that.
LTAG match can distinguish things, but you're not using LTAG match on the equations definitions.
I have that.
Jason might.
How much more time do we have to discuss?
I think that's it.
Let's move to the next topic.
I would like to say that I don't know what is the progress on the work of extraction, but
Equations or extraction?
well, extraction in general and extraction for iteration. But this is another place where you will really have strong expectations from programmers.
Yeah.
So maybe we will need to have another pass at that time to recheck that the extraction is satisfactory.
Yeah, but the expression also does. It does a lot of optimizations. It does commutative types of match and application, so it puts all the applications in the leaves.
It inlines linear let bindings in some cases.
Yeah, in some cases.
But in a way, inheriting information from the initial form of the code for later situations is something that will be needed in long term for the whole code. I see it, for example, also for graphs, for DPD graphs, and for documentation purposes.
Okay. That's it for me.
So you are taking a decision?
I can implement both and do that mode where I use inspect and have abstract length by default. That's right.
I just to see what is the conclusion of this discussion.
If you can write notes, happy. Ready? We ready?
No?
Yeah.
You want to have a little break?
We can have a little break. We have until noon. So yeah. We only have these two topics scheduled.
There is coffee. We have private coffee.
Yeah, private.
The amount tomorrow there is a break in next to downstairs, but not today.
So break until 11?
Oh, that works as well.
We did a round table earlier before you arrived. So,
I'm Ali. I'm at the University of Gothenburg. And that's it.
You are interested in what topics?
I'm studying logic at the University of Gothenburg.
No, but around the code development? What
About code development, I mean, I'm mostly working on the tooling and the LSP stuff at the moment. Is emplacement du personnel. Share your screen? I don't know. Okay. Yeah. You want to go to screen or I think it's
Souveraine vision. So not even. At least the interface is French.
So
except that it's a sovereign Cisco system. Exactly.
Maybe a tiny bit bigger.
Yeah. Well, and maybe you can fold back the things on the side if they are not important.
No. Maybe you can even have the rendered version.
The rendered version.
All right, you just click on
the top right.
Okay.
And still bigger.
Still bigger?
Yeah.
I don't know if I can zoom this in my phone. Ah,
There's
Yes.
okay.
It's okay.
So I've been working on porting the test suite to Doom. This has been going on for like more than a year now. So this year we switched from the make-based build system to a Doom one, but we didn't switch the test suite. That was still a make file that we basically manually have to run. In order to do this, I've gone down the route of generating our own rules, like we do for the main theories build. But these rules are kind of special because we want to test things. So a lot of this work is basically taking the make file and trying to replicate the same behavior but using Doom. And so here, this is which PR. If you want to follow and check it out, it is 16583. So I've mostly tried to keep it exactly the same, but there's some differences between how it works. But if you want to just run the test suite after you've done a change, the easiest one to do is just, let's say, make test suite or make test. I've added the shorter version as well. The details is that it basically generates the rules that it needs for the test suite in the background, and then runs them. And because this is in Doom, we have all sorts of refined targets. So now we can run specific tests if we want to. We can run tests in certain directories. We can make it also, all the dependencies are correctly specified now, or are supposedly correctly specified, which means you don't have to make the full build and then run the test suite like we do now. You can say, oh, I want to see if this test is running, and build it, and Doom will go and find everything it needs. All the tests are quite complicated in terms of what they're doing, but they're quite different. The basic ones are like, if we have a look at the directories here, so this is our test suite today. We have bugs and failure and so on. But these are basic on output as well. Those are the main kind of folders people use. Those work by just running Coq and perhaps checking for output. So those are very simple rules. It's the other ones that have a bit more of a complicated setup. So actually most of the rule generation is kind of accounting for that. But I can walk you through what you need to know in order to use it. So it should be simple to use. And if it's not, well, please let me know if something doesn't make sense. I've written some preliminary documentation, and I got a nice message from Jim this morning that the documentation is not technical enough. I mean, it's too loose in its wording. But I guess we can tighten that up and clarify anything that doesn't make sense. That's not a problem. So the main thing we do is you run, make test, and let's say you made a change that introduces a failure, okay? So this is the dealing with failures. So it will output some scary looking output like this, right? The reason these line numbers are so huge are because these are the generated rules. But this file we'll never have to inspect by hand. But what happens is that Doom says, well, I tried to run this command and I got X code 1. So this failed, right? And you want to know, okay, what is it exactly that failed? And in order to do that, I've added more specific commands. So, when you run make test, it's just building all the tests, the run test targets, right? And this is just a set of targets that say, okay, this is running the test. You can be more specific, so you can say, okay, do and build, I don't know, bugs, this one, but you have to build like the VO. In order to make that simple, I've added a way of making that shorter. So I'm going to open the terminal, hopefully it works. So the test suite is now set up, but we can do like, if we have a test that we want to run, I don't know. What's your favorite test?
Modules math.
You need binders.
No, that's not going to work. It's going to take ages.
No, it's finished. It's pretty quick.
Okay, like this.
Yeah.
Okay, so these are all defined in the generation. So my laptop is awfully slow at the moment. If I put it in performance mode, maybe we'll see it run. So Dune is now running, building all the targets that it needs.
So it's
this is probably building
part of the std, no? It's building part of the std, no?
It's building part of the standard.
Yeah.
Yeah, like this presenter project. Yeah.
You should use a short display short so that we can see it.
Yeah, we can also
It's a bit late.
Yeah.
So I don't enable display short because it's quite verbose, but at least it will show up the commands that are being run.
So Dune has got quite a slower in the last releases, by the way, in terms of serial build. It's another thing.
That's something else we should check. But
So what does it say?
so here you can see it runs some commands. Don't worry about this. This is just the cache for, what was it, Leah. I had to do some very interesting backwards bending in order to get that to work, but that should work most of the time. The main one is that this is the test I ran. And what it's saying is that it's produced like the glob and the VO from running Coq-C, but we're also capturing all the logs of all the tests. We're not actually diffing most of them. We're only diffing the ones in output tests because there we have an expected output. What this means is that you can go and like inspect, let's say, so this will be in the build directory, it's going to be in test suite, output, universe, and then v.log. This is that test having been run.
It could be promoted if people would like to, right?
No, because this one
is an output
yeah,
test.
oh yes, that one will get promoted if it's changed. In fact, we can change the test to see how it works when it doesn't have the expected output. But the main thing is that that's how Dune builds it. I also, this is doing more than the other test suite does now. So
the promotion is for targets. There are two issues here. First, the catch is because the catch, the way it is the catch is very unfriendly to build systems like Dune that are functional, because actually it's a kind of fixed point computation. So for example, I mean, you are updating a file in place, and this means you have to disable all the kind of caching. You cannot assume functionality. So this is what.
But I will explain promotion in more.
Are you going to explain promotion?
I'm going to explain it in more simple detail later. But the main thing to note is that we run Coq check on all the tests as well, because Coq check was very under-tested as a program.
It is still under-tested.
It's still extremely under-tested, but it's doing better now. But
why does it say that it checks the log?
That's the target that is produced. So this is
it's check.log.
This
is the output of the work. Okay.
But you mean we used to not run Coq check on those?
Not on everything, no.
Not on the output tests.
Oh, really?
Yeah.
No, I mean,
so,
we didn't run it.
Yeah, so for those not used to Dune, this is the command run and this is the output.
Yeah.
So you see?
What happens with the output tests that where the command that fails?
Yeah, okay, I can show what happens. So if we go to
But this bug that we are looking at, unique binders, well, this test that we are looking at is not an output test.
Yes,
yeah,
it is. It's in the output repository.
So the head,
oh yeah, I didn't check that.
the head unique binders is the name of the file.
So this is universe binders, right? And for instance, we can change the test. Sorry, Coq LSP is really eager to start. We can change the test so that the output is different. So we can do this, for instance, right? And if we rerun the test suite, so we rerun universe binders, so it's going to do it.
Oops.
So now Dune has complained that, well, we had an output that we were expecting.
Can you remove the notification?
Yeah, sorry about that. We had an output that you were expecting, but this is not the output that I got, right? And it's giving us the diff, okay? And if I wanted to say, oh, actually, this is the output that I want, I can what's called promote this output. This means that we copy the new output and we can replace the old one, right? In order to do that, I can just say, I can't see what I'm typing, but to promote. And this will go and take the log and make it the new or the output. So I haven't changed the names of like the .out ones that we have. For instance, in the output test, we always have something .v and the same name .out. So that's still the same. So that hasn't changed. I don't want to do that, so I'm gonna.
Do we now have the so you generate aliases for every test? So that means they need to have unique names for every test?
No, we don't have to have unique names. So Gaetan asked this question on the thread, and in Doom you can, let's say, okay, universe binders is a unique name, I think.
Yeah. An alias is a set.
Yeah, so an alias, when we talk about aliases in Doom, that's just a set of targets. So these are just little single tool sets. The reason we're using them is because it's easy to type. We can just put @ and then the name of the test. That's how I set it up.
So just produce everything that is in that set.
Exactly.
So this is how you extend, for example, a group of things in Dune.
Okay.
This is how you can make your alias for your own Pierre-Marie set of tests.
So if we said that universe binders was not unique, say we had this in 2 different test folders, we can be a bit more specific. We just have to say like that. That's not the right folder, but you know.
I think it wants test suite to be included in the try running that.
Yeah, you're missing the suite. Well, that's okay. I need to put the full path, but yeah, you get the idea.
Okay.
So I mean, that's one way of running specific tests, and that's how you, for example, promote the output. This also means like when we add new output tests, all we have to do is put the V file, and then we can just promote it immediately. We don't have to like touch a file and then like we do it with the current test suite.
Yeah, so something that we discussed earlier, so it's also related to the general build. Like Dune, there is something called the way the incremental system works is more technical, but basically the first way to organize the target is by directories. So usually, it's because Dune is really very dependent on directories, because this is actually what you use to not to have to recompute the global set of effects when you do an incremental. So in general, you can always say Dune build a directory, and it will build all the targets under the directory, or you can put an alias under a directory, or you can put all TMAT files, or you can put whatever you want under a directory. So this is general for Dune build. It's not specific to testing. So yeah, it forces you to organize your development on directories, though, if you want to. Yeah.
Okay, so that's how, bugs. If you have a bug that you want to see, go on, question.
You said that you had the possibility to run tests before having done a complete build.
Yes.
How do you know which parts of the code this test is depending on?
So if it's running Coq C, that's most of the code already. But if it's when it comes to the standard lib dependencies, we're just using Coq dep behind the scenes. So we say, okay, I have a file, I Coq dep it, and then I pull the dependencies manually, and I only build the ones we need.
So you say not a complete build means you don't have to do all the .v files, but you still mostly have to do all the .ml files.
In fact, the speed up is dramatic because so that was the main motivation to run Coq dep in all the test suite. So, well, we have to patch, took us a long time, right? We have to patch CopDep a lot in able to, for CopDep to run, because otherwise, so actually the difference is dramatic in the sense like I think 99% of the tests, they just depend on the prelude. So you can just run you can run the test suite much quicker.
About the speed of the test suite, at least on my PC, running clock check takes as much as running the rest. So would it be possible to do all the clock checks in the end rather than?
Yeah, so I mean that's
or disable it
or not. Yeah, I mean that's also completely
They could
possible.
be separate aliases at least.
Yeah, so at the moment
It's possible.
we run the clock check test as well as the V file test in the same alias. We could change that so that there's a separate thing.
And you're running cop check in the full mode, not saying admit that the prelude is right already?
No, I'm admitting.
Then it's rechecking all the same things all the time.
No, as in we're...
Yeah, you admit
no,
some things?
I'm not checking the things before.
Okay.
Yeah, so usually these kind of things, Enrico, are easy to do.
Uses no
As long as you can do that incrementally. What is a bit of a disaster is if you have a situation where, for example, imagine you run the test suite without code check, and then you can say, oh, now let's run code check. When this is a disaster, is for example, is for running code check, you have to run all the previous stuff too. Okay? So I think for code check it's okay because it's totally incremental. You just want to face with VO, and then you can run later code check, so that should be fine. I mean, if it's not fully implemented, it should take. Yeah. What you are a disaster is when, for example, you want to run something with a different configuration, and then all the work you did before has to be written down. Yeah. Then you're in shit.
Let's make a test that fails, so we see what that looks like. It's not an output test. So I'm gonna, I don't know, do something naughty here. I don't know, like admit. I don't think that works. So
No, it was. Well, it will say no more subgoals.
Exactly, it will compare. But if I do,
Should at least.
was it bug 1425? You know, try to run this now. See what it looks like.
So where are the aliases stored?
So we generate all the rules, and there's a huge list of doing rules, which say I'm in this alias, I'm doing this alias, and so on. If you want to see what it looks like, it's.
You can add new names. So where do you edit that?
So I do this in this ML file called generals. This is the thing that actually generates the Bloom file itself. So roughly it starts here at the bottom, like this. Okay, so we have these procedures called check directory. And for instance, the output checks are done here. Don't worry too much about all these other details. This is just like modularity. And what this does is it says, I'm testing the output directory, my dependencies that don't worry about it actually. And this will generate a lot of rules. And those rules look like this. And you don't have to ever see this, but behind the scenes, this is how it works. So, test suite do. This is a huge file. So if I do this, my computer's not going to have a great time. But for instance, if we have a look at
actually, we could split the files, no?
Yeah, we could split
That
the files.
will
It doesn't matter. I'm just dumping them in the same one. But
It's okay, it's only a quarter million lines.
Yeah, I mean, don't open this file too. But the point is that it says to do look, I have a rule. In this case, the alias that I'm adding it to is this one. Here are the dependencies. These are all resolved in the ML file. And the action is, I don't know, set the environment. In this case, we want to have backtraces. So we set the OCaml backtraces to be true. And then we like run clock check with all the arguments and the correct. It is hashed because this is replaying a rule to get the backtrace, but it can't be the exact same file. I'll go into that in a second. That's.
So you were doing something before I interrupted you.
Yeah. So I mean, I was showing what happens if we run this rule, right? And then we got this nice output. So I tried to run doing build this bug after I changed it, and then it just dumped this, right? So don't worry about this output when you get this. The important thing is at this point, you want to know what actually was the error. And in order to do that, you do this. So I added a thing called a debug alias, let's say, and this will rerun the exact same rule. This time it will output the erroneous, like the std error, and including a backtrace onto the console, so you can see what the actual error was, and you don't have to go and inspect the log file manually. That's the main thing. So this is just gonna do that, and here's the error. So yeah, no such goal, because we tried to admit something that there's no goal, and the backtrace is there from and that's fine.
Backtraces are kind of spammy most of the time.
Yeah, so I mean,
I prefer having them opt-in. Putting set debug backtrace in the file is pretty easy.
I think, yeah, we could probably do that. That's no problem. Yeah. We don't have to have the backtrace. So yeah, I mean, this is what the outputs look like for failing tests. I did some CI engineering as well. So having this kind of output, you don't have access to, you can't just go and run debug in the CI because you don't have access to the CI console, right? It will run the test, but you'll get this kind of unhelpful output here. So in order to understand what went wrong, there's a script in the CI that will rerun all the failing jobs and just output them into the log. So if you, I don't know, upload a new commit and you want to know what went wrong, it will just quickly show you, okay, this went wrong, here's what it said, this went wrong, here's what it said, and so on. So I've tried to keep it informative. Especially on the CI. So if you can test that and tell me how you think it's working, that would be good.
Actually, Ali, before you said like you were running, like why do you need to rerun in this point too? Why do you need to rerun?
So I have to rerun because by default everything gets outputted to the log file. Even for tests that are not output tests. That's how I capture the logs.
Yeah.
When I capture the logs, I don't have access to the whatever was piped.
So whatever was
piped from the.
I don't. What you lose? I don't. This is what I don't understand.
Okay, so earlier when Coq failed, right? All its std error got put into a file, so it doesn't actually appear on the console. So the debug one just does the same thing as that test, but outputs its errors to the console, so you can see it. So this is the error here.
Can you just output the file? Why do you need to run the test?
Well, you can't depend on the file because the rule failed.
Yeah, because it's a failing rule, we don't have the artifact.
But then we have a way to. We discussed that. Okay. Yeah. Let's put. But I think we have a way to actually.
You could have a two-step thing. You could have a rule that generates the file and never fails, and then a rule that checks if it's supposed to be an error and actually does the failure error. So like you have the first rule. It puts everything in the file. It says if Coq failed, I put the error code in a separate file, otherwise I put 0 in a separate file. And then the second step, which is another rule, which checks the separate file and then returns with that error code.
Yeah, I mean, that might be possible. I didn't set it up that way, but we can change it, because the way the rules are generated, I've tried to make it at least readable, so it can be maintained. I don't know. One of the problems with the old test suite was that the make file was kind of hard to know what was going on. Only a few people had kind of the knowledge of how it worked.
I'm not sure if it's going to change very much with this.
Yeah, I don't know.
Yeah, the thing that you that's actually the thing is you still need to make the rule to fail. So actually instead of the test rule failing, you need another rule that is expecting the subtest. So yeah, you need 2 rules for that. But yeah, okay.
But I'll go back to how the other tests work.
Yeah.
I think having the Coq depth support is a much better selling point than maybe people will understand it better than Make5.
I see what you mean. Yeah, I mean, so the main thing is if you have a test that you're interested in that's failing, you can run it directly without having to run the entire test suite or knowing how to build what you need to build in order to run it. So today, let's say a test that uses like the real numbers library is failing. The workflow today is to build the entire standard library because you don't know exactly what it is. Or you might do, but it's a pain to go and check the dependencies yourself and build them. Now you just run the test. So that's the kind of improvement in the workflow. So adding a test is easy. You don't have to change anything. You don't have to add anything to the MO file. You just have to plop your .v file in the correct folder for most of the tests. Depends how you set them up. So here I talk about like promoting. So you can promote specific tests, like say if you want certain output tests to be corrected, you can do that. It's not a problem.
Is there a way to say just promote everything that can be promoted?
Yeah, just right click promote.
That did not do anything for me when I tried it.
Okay, I will show me that later. Yeah. So the main new thing is that you can run single tests easier. You could run single tests in the old makefile, but it was a bit flaky. Sometimes it worked, sometimes it didn't, because of the dependencies being incomplete. We'll see. The other thing is, you can build multiple things as well. You can check 2 tests if you want to, or a whole folder and this and that. So you can mix and match that.
You mentioned you could rerun just the tests that failed, right? This seems to be the...
Just the ones that failed?
Yeah.
So if you ran a command and it finished, and some certain things failed, and you rerun that command, only the failures are going to rerun,
Okay.
because it wasn't able to complete that rule, basically.
So what if I have a flaky test and I want to run it 10 times because it will fail 1 time out of 10?
You have a flaky time? Sorry, a flaky test?
A flaky test?
Like a non-deterministic bug you're trying to investigate.
Okay. So that's interesting. What kind of use case or what kind of thing are you thinking about? Like miscellaneous?
A rift and drop-out.
Anything involving parallelism.
In the async test suite CI job, sometimes it fails, and if I want to try to reproduce that locally, I need to basically run the command 10 times or 100 times or however many.
So if async fails in the CI, you will have access to the exact log that was run.
I want to reproduce it locally because I want
that's what I mean.
try to change something.
You will have access to exactly what was run, so that failed. So you can know how exactly you can rerun it. It will just be a shell command.
But then he does a shell script, right?
I think Gaetan wants to rerun something that worked.
Yes.
Until it fails because it failed randomly.
Rerun something that was working.
Yes, so you have 2 choices. Either you disable the cache and just force the target to be rebuilt, or you can use the show command output and just cut and paste the command. Yeah. The good thing about this is there is not a lot of magic. You can see in the log what command is exactly run and cut and paste.
But so you don't have a fine-grained clean command. Just erase one artifact.
The problem is Dune is functional, so even if you erase it, it's not going to replay the rule because it will be in the cache. So in general, that's the thing. It's really memoized. So you need function to disable the cache. But you can do that.
There is no option to force a target to be rebuilt.
Yeah, but this is actually interesting that there is. But this is actually a bit interesting. It's not intuitive. It's not intuitive what you do because.
My computer is not functional, so
you may need to listen to what Maxime said. You may need to clean more than what you expect to actually run. So in this case, I think it's better to actually just run by hand. You just cut and paste the command and run it by hand. I think. Well, you can do the cleaning. Okay, you can do the cleaning, disable the cache, or you can have a mode for that. Yeah.
So Gaetan, to answer your question maybe directly, when you run the test, the last thing that was run, let's say, I don't know, some async thing, Doom will give you a shell command that you can rerun to do that exact same thing.
So
if you want to manually rerun it 10 times, you can just copy paste it.
Although sometimes there used to be CDs in that command, so if you just iterate it naively, it doesn't work.
But it's a
You have to open it in a subshell.
No, but
it's already.
The thing it gives you is already wrapped in.
And does it also set the environment? I mean, this shell line does also.
We try not to touch the environment too much.
You showed one before with the backtrace.
That had just the backtrace.
Yeah, that will be that the local environment will be replaying this rule. The thing is, the problem is at the level of the rules, you don't have this. So this can be done like a tensor, it has to be a bit meta. At the level of the rules, you cannot affect the cache, for example. So what the Gatan says is hard to do as rules. Because you cannot do in a rule. Well, maybe you can. Can you disable the cache in a rule? I mean, that would be a good issue.
What Gaetan wants to do, I don't think it's
You
worth.
can depend on universe or something.
Exactly. This is what I was thinking.
So
Yeah, actually, it can be actually have a forced target. There is a special dependency. So you add to your rule a dependency on universe, and it's always going to be executed. It's never up to date. Yeah, so you can do that.
So you would generate a new rule with the additional dependency that is.
Yeah, we could just add another alias that depends on the special thing that makes Doom.
You can have an alias which is always run, not always.
That's how the debug rules can depend on that, for instance.
That could also work. So this is how the cache is updated today. It kind of depends on the universe. That's why every time you run it, you see that the cache is being done. The reason that is because some tests want to use the Lea cache, and it's very hard to keep around and up to date. But I managed to do it in a way that when it needs to be updated, it's just the same way as before.
No, just the problem is a trace category then, and Dune doesn't have fixed points. Could be implemented, but there is if your cache is both input and output. So then, usually the systems that support that they like to reach a fixed point. Otherwise, it's not. But yeah, that's.
I've tried to write a little bit about how the rule generation works. There's just basically two files that we care about, which is gen rules and Coq rules. These are specific Coq commands that get run. The rules for generating them, so they look like this.
So this is a similar system as for the standard library?
It is a similar system, and it was actually written before that one, but then Emilio wrote that one.
Yeah.
And for the standard library, we have a problem where when there is an error, the file name
Yes, that's very annoying.
How do we do the same thing here?
We can fix that later today.
Let's do it.
Yeah.
Put a bounty.
We can fix that.
Half a beer for whoever.
But actually, get to your question, I think before merging, I like to spend some time with Ali this week to remove the duplicity. I think I like to share. I think we shouldn't have two rule generations, but they are very.
I'm of the opinion that keeping two rule generations for the time being is fine because this works, and then trying to merge them is a better idea rather than trying to merge them and having a broken PR that we never merge.
Okay, you may be right, but this is very easy work to just the code. I know the code well, and the right code is the one we have in the standard library. As you say, I wrote this code before. This is something that will take like an hour. So I think I'd rather not have this duplicated rule generation. That's easy to fix, Alex. Don't worry.
The problem that you talked about is it has this problem. So as you can see, it's not in bugs, right?
Yeah.
So that's a little bit annoying.
It's even worse because now we have a hash in the middle. But yeah.
No, the hash is something that you should never think about. That's just this specific one I chose. But like if I run, what was it? Yeah, the hash was just there to show the error message. That's how they.
Does the hash need to be actually unique, or could it be just underscore debug?
The problem is I want to rerun the test and also produce the same targets as the original test. But then we'll have two different rules producing the same things and doing the complaint. In order to make it unique, I just basically hash the contents of the rule and then just append it to the end. That's like my hot fix.
Whatever.
But would it be enough to just append to the end underscore debug without a hash? Assuming we never name a test like that.
That's the problem. So I was like, okay, we could do it like
we
that.
Could also name a test
with a hash. Yes, there's a risk of collision. You never know.
You know what? It's a good point. But yeah, we can make that look prettier. I think that's not a problem.
Can you show the code again? Exactly what was on the screen before you made the shell bigger. There was a list of hardwired paths.
Oh yes, I can show those if you want. So this is
What is that? No, the hardwired thing.
down here.
Yeah.
So these are the IDE tests. So this is the fake IDE test folder. You know, when we're running that, I manually put the dependencies for that in. So for instance, we want to depend on everything inside.
Because there is no cockpit for the fake ID file.
Okay.
Yeah.
I see.
Yeah.
But it's just depending on the prelude, and this was just handmade from the tester. And in package Coq core is just everything with Coq C and all that. Like we're running the Coq talk tests and so on. So we have all these miscellaneous tests as well. The makefile tests are like this. For example, at the moment, makefile tests all rely on the whole standard library because I don't have a way of copying the contents of the folders of the makefile tests and checking exactly what it means at the moment. We could refine it if we want to, but I feel like at this point, you know, you can. If you're working on makefile, you're not working on the code itself. You know, it's like
I'm not sure about this.
maybe I don't know. It could be.
What was the answer of Gaëtan?
I'm not sure that what you said about if you're working on makefile, you're not working on it.
No, but you're working on the Coq file itself, you know, rather than it won't rebuild the standard library if you're editing like how the makefile works. But if you're suggesting that you're changing,
that doesn't mean I have the standard library.
no, but if you build it once and then
I
you
don't
have
want to build it once.
you don't want to build it once.
I want to build it once.
But I mean, I guess we could spend some more time and refine that. But the makefile tests are not the most commonly used tests as well, so I didn't put that in priority. There's actually another way we could set up a lot of these tests because I've tried to keep the compatibility with what we currently set up. But there's better ways to set up, like for example, the MISC tests, because they're just running arbitrary shell scripts at the moment. But Dune has a way of testing shell scripts called cram tests, and we could use that. But this is something that we could do in the future. It doesn't have to be now. The tools directory was very fun. There's all sorts of other random tests doing random things in there, but you know it works. And then we had the miscellaneous test. I couldn't get it to work on Mac or on the CI. I had some issues with that, so for now it's stuck behind the Linux.
What kind of issues?
We can have a look at them later, I think. But
Was it running before or not?
yeah, I'm not certain. I'm never super certain if it was running, but I think it was. I mean, like, I also spent time and like converted the complexity tests, for instance. I mean, there's also the way these tests work is that they run some extremely large term and then check the time if it grows like ridiculously. The way it tests how to time these things is quite interesting. So it's like, have you ever heard of BOGO MIPS?
Yes.
Yeah, so this is an extremely kind of, I would say, hacky way of testing the timing of the CPU in Linux. It doesn't work on Mac, really, but this is how the times are done. I would suggest that we convert this test to kind of proper benchmarks in the future, but for now this is compatibility. They weren't actually being run in the CI for macOS before as well. So
I totally think we should just get rid of this test and instead
No.
put that on the bench.
okay, maybe on the bench, but I'm not a fan of getting rid of things because these are useful.
Did anyone ever use it as an indication of something?
So it fails. It does fail at the time. So I think we actually caught a few errors that way, but most of the failures are actually spurious. So you get a random.
So it happened to me once. I was working on the guard condition, and I introduced an inefficiency.
Quadratic blower.
I think those fails.
Yeah,
it's still useful.
So they can be run. If you want to run it on Linux or on macOS, you're welcome to edit the code.
Actually, for that, for example, what is used in other common libraries is a package called CoreBench. I don't know if you know for it, folks. Yeah, it's more about micro benchmark. It's more like unit testing, of course, but maybe that will be more useful.
Yeah, I mean, this is part of a general discussion we had.
To start with, indeed, CoreBench runs several times a test and takes an average.
So you say, I want to run this function like 100 times, and it should take this long, and it will do that. And this is all just in a camel as a kind of inline test. That means, the output is done all in the ML file. That's something we could investigate and use in the future, but for now, the test suite is just keeping compatible. It's just switching from one system to the other. I don't want to introduce new kinds of tests at the moment. Any questions? And I will take any questions. Because if this made perfect sense, I would be surprised.
No, I mean, my point is that before we had to maintain an ugly makefile, now we have to maintain this. How big is this? How many hacks are there? You mentioned a few ways to bend the dune. How many?
How many?
How hard is it? How many hacks are there?
Is it a clear improvement on the makefile maintainability? I guess that's.
So at the moment, the way the test suite is run in the CI, only a single hack is used, and that's to get the Leah cache available.
Yeah.
But I've included hacks so that people can debug the test themselves. So that's not actually included in the running of the test suite. So these debug targets, they're only for people to manually have investigated.
So this file is. So for example, the fact that you had to hardwire some dependencies, I mean, it's not a hack, but it's something.
That's
because we
It's also done in the makefile.
Explicit is better than implicit, I think. So in that sense,
No, I wasn't confused.
I think Enrico actually, I think it's an order of magnitude less, more clear to me. Actually, as Ali mentioned, the nice thing also, I think this gives you a path to actually remove all these hacks.
What is the size of this file?
This file
Can
is
we
only
go to the last line?
It's only like 300 lines.
Yeah, it's very declarative script. So, but actually, all these dependencies, for example, you can actually, you have a system to inject dependencies. So, for example, for fake ID, well, fake ID is not worth it. But for example, when you do a cram test, if you compare a test from a doc shell script to a cram test, then you will understand the dependencies of this shell script. So then you don't have to put them here anymore. They're automatically maintained.
No. We still have to do this.
Well, it depends for what. For example, for binaries.
But when we run something like Coq makefile, there are certain environment set things, things in the environment that we need. Like this file has to be here, and so on.
If I do echo require blah blah in AWD and then Coq makefile.
But for example, it will detect that Coq makefile is dependent. But then of course you need to inject, if Coq makefile has some dependencies, at some point you need to inject the dependencies. But there is some kind of path to remove some of the stuff after the explicit dependencies here. Of course, having all of them automatically, I think is not feasible with all the scripts we have, but could be improved a bit. Yeah.
Okay, so what is ignore are things
that didn't work. So, for example, here's a bug that CopCheck chokes on, but is compiled. This is due to functors of modules, and Pierre-Marie told me that this probably won't get fixed anytime soon. We can just ignore the running of it rather than the checking of it. That can be done, that's not a problem.
This bug blacklisted even before. This is if it was blacklisted even before, it's fine.
It wasn't blacklisted because we were running CoqC on it and it was fine. But now we're running CoqCheck also.
Is it an output test?
No, it's in bugs.
So what? I thought we were running CoqCheck on all VO files produced by.
We weren't. So here's an example where CoqCheck doesn't like.
There were even full directories ignoring the test suite.
The output test I heard before, but in bugs also.
Yeah, we weren't running.
Yeah, the makefile. Well, this is a try to read it. I mean, I'm trying to understand what it does. I mean, it's
which one? 29, 22?
This one, yeah.
The load one can be fixed by the way,
This one is Coq depth parser doesn't like it. It's literally just a single curly brace that's being opened. and when you feed this to Coq Pep, it's like, what? No, it doesn't like it. So
Interesting.
I mean, I could kind of hack in a way of saying, oh yeah, don't run Coq Pep for this specific B file, but it wasn't really worth it.
I could fix Coq Pep.
I need to move this test somewhere else. It can't be in bugs. It has to be a bit more special.
Or we could fix
Or we could fix Coq
Okay.
Pep. That's also.
I think there are many code bugs. We feel some, but there are many code bugs.
I mean, I've also actually fixed this before, but I didn't submit it. But load is a bit difficult as a command. Coq Pep gives a different path to the one that I want, because I run Coq Pep from the root of the test suite, but I run Coq C locally. So it gives the wrong.
But this was working. This we can fix. I made the correct at some point. So yeah.
Yeah, I mean, getting load to work it could be done. It's not worth it at the moment. This one is new. I don't know. Someone added this recently. It broke this week.
What happened with this one?
There was a problem with.
Oh, lovely.
There were only there were only two, because there were only two. The brace one that put cut that to
What was
death.
it called?
091. 06.
Yeah,
So-
I understand why.
Yeah, so this was not liked.
Oh, weird.
This is like
Do you pass the async cache force?
Yes, so all the header arguments are all passed correctly.
Why this is not?
Yeah, I don't know. I mean,
Because you're consuming OCaml memory every time you do declare ML module.
So this bug happened because
I know, it failed.
because when we introduce a rule, there may be keywords in it. So we add the keywords to the Lexer state, but we also use it to count the number of occurrences of keywords. And then when we remove a rule, we also remove keywords if they had no occurrences left. But there was some issue with the counting, so that we ended up with the wrong number, and so it did some random nonsense. And in fact, this automatic removing of keyword was completely useless, because the thing we did after removing the rule was setting the Lexer state to something else unrelated.
Great.
So
why does the test fail now?
So you did add this.
No.
It's failing. The test is not failing itself. The rule generation is failing because it can't find a meta file.
Yeah, this is because the meta, because this is
You have to hardwire something about the.
The thing is that is this back in code depth is also registered. This it makes this can be fixed. It's not a big deal.
So one nice thing about this port was that I discovered quite a lot of problems with Coq depth and just general Coq. Hopefully we can fix them.
So you're telling us you have 300 or so lines, but some of them are actually needed just because of the bugs of the tool around.
Yeah, exactly. Sometimes the setup for Coq Makefile is kind of standard, but then things like the standard lib folder needing to be available because of some environment or initial Coq environment setup, that's kind of annoying. I don't know how to get around that. There's like this Coq lib error that comes up when you don't have the correct standard library. This is because we have something called noinit, which is running Coq without the standard library, but it's very incomplete in the sense that most of the time you do need the standard library for it to work.
But I think it's good that, it's a tool that is supposed to run when Coq installed, so it's normal that you need it.
Yeah, I mean, that's fine, but we're being more explicit that it should be there.
Yeah.
Now, so, but I mean, that's something we can improve in the future, making the detection of various files better.
What worries me with what we saw in your demo is that the error messages are too bare bone right now.
They're too bare bone.
They show too much of the Dune technology and too little of the infrastructure or the way to progress.
Mm-hmm.
See, when you showed that you obtain an error message that is unreadable and you have to run another command to recognize. This is
So this is what I was saying with the CI. So in the CI, you will also get this unreadable Dune output, but then there is a script in the CI that will rerun the test, so it just looks like, oh, Coq failed here with this error, Coq failed here with this error, and so on. Because I don't want people to touch the Dune file manually, you know.
But if we do the two-step whole thing we talked about, then we can.
Yeah, that's an idea we can.
Yeah. No, this can be improved if I agree to be improved. The thing is actually we were maybe trying to get more help from Dune itself instead of adding ourselves. Because for example, the summary, this is a bit a trade-off. For example, before the test suite built a big summary log. But for example, this is a bit annoying because imagine you can do the same in Dune, but then it means you have to wait for all the tests to finish before seeing the log. And usually you want to see the failures early. So
one of the
I really don't agree with that one. I like having my summary after having running all the tests. So
no, this can be done. Everything can be done. So both things can be done. Yeah, both things can be done actually.
But a follow-up. I mean, I asked a question about the maintainability of this. The follow-up to me was, it seems weird that in order to run tests with Dune, you have to do all this thing. How much of it should go into Dune proper, and how much of it is Coq specific? I mean, seems like that they give you a way to run tests, which is call a target, and
so
zero support.
There's multiple reasons that we're generating the rules ourselves. It's related to the fact why we're generating the rules for our authors. You know, Dune can build Coq projects today, right? But we don't use that in the main repo.
This I agree. I was thinking about, like, for example, the summary. Maybe it could go upstream, and when you run a test, there is a way to tell Dune that this piece of info should be displayed at the end in a summary. I mean,
so when you run the test suite, usually in a Dune project, you will get something that looks like a summary. But the thing is, Dune is really for OCaml. So these kind of things have only been done for OCaml. This is the first time anyone has done it for Coq. So obviously it's not in Dune.
Yeah.
But we can put summary things in. That shouldn't be tricky. But
this was just the last thing that was mentioned. I don't know how many other things there make sense.
Actually, there is not a lot, Enrico, because for example, the diff and the output tests are already in Dune. We are using the Dune technology. Thing is, for example, this is something I like. Dune has this philosophy that a successful build should produce no output. And I agree with that, because the moment your build is producing warnings or things, what people do, ignore them. Or in CI. So for example, like the way it's used at industry is that actually when you run the test suite, you only see errors. So this is what there is not a lot of support for making summaries. Because I mean, you just see what needs your attention. And this has been shown for these people. I mean, I don't know, but the Jane Street people are very vocal on this in terms of developer productivity.
I don't know. I think that's just a personal preference.
No, there is studies that show that systematically, if your successful build outputs something, then you tend to ignore it. For example, if you have warnings on, or if you have like output, then you tend to ignore it. There is studies on that, actually, scientific studies. So
I mean, I guess
preference.
Test suite is not noisy by default. So if tests are successful, it doesn't show that.
Yeah, so
it only shows what goes wrong.
I mean, we argue a bit this summarization, but this was a bit the answer we got.
Okay, one of the
other
reasons
thing was about the flaky tests of Gaetan. Since it's not Coq specific, I mean, it's not the only piece of code that does some I/O or some threading or some. Even with Camel 5, it will become more and more present, I'm afraid. So maybe this should go upstream in a way. I mean, this.
Yeah, I think for real-time testing all this stuff, I think people are using different tools. Yeah, should go, but yeah, but I'm not sure Dune is gonna, because Dune is really a pure incremental build system. So for example, Jane Street, of course, they test a lot of network technology that is very sensitive, but they use totally different tools for that. Because actually they use more like concurrency tools that can produce a set of reduce a set of possible traces to a set of traces which is complete. So this is a more fancy technology, at least in the scale Dune was developed.
So I'm just thinking, just run it without using the cache on the command line instead.
Yeah, you can run like this. But people testing flaky stuff, usually they need to they want to test all possible traces and use some trace partial pre-order, no? How it's called, this trace pre-order, and actually do a trace a pre-order reduction. So in general, it's a bit this it's almost model checking actually. So,
but
the unit is not used for flaky tests. It's a big assumption it has.
I would like to maybe make a point, which is the reason I'm showing the test suite today is because I kind of want to stop writing it myself. I want other people to kind of join in and say, oh, I want it to work this way, I want it to work that way, this is easier, this is not easy. So this is, I mean, my hope is that we can get this merged and then people can open PRs and improve parts of it. About the maintainability, like while I'm here and thinking about the test suite, you can ask me anything about if something doesn't make sense, how is this supposed to work, can you clarify this? And I want to try and document it as well as possible. So I don't just leave a load of undocumented code. But yeah, that's my presentation. Yeah.
Thanks.
To me, it seems, frankly, it seemed fine even the other time you presented it, so I'm not so sure.
The other time I presented it, it went wrong while I was presenting.
Yeah.
Another 6 months later, it's working.
It will go wrong again, and we will have to fix it again.
But the thing is, if it's going wrong while people are using it, they will fix it.
Yep.
Because a lot of the work I've been doing actually maintaining it every other week is, I don't know, someone has some new tests, and that does something I didn't consider, and I have to update it. So I don't know. We have to do everything in this generation, but I've tried to make it as kind of simple and declarative as possible so we can be maintained.
No, in a project of mine, when I moved it to Dune, I had to do something to replace my makefile crap with something else, and I took a completely different approach.
What did you do, Rico?
I wrote a program that does the tests as I like. So I implemented the logic in OCaml rather than in Dune, which gave me a lot of freedom because it could do what I wanted.
Yeah, that's also doable.
Yep, the main advantage you have in Dune, well, first, of course, there is this big constraint that is people is complaining about the non-deterministic BO files. The big constraint you have is pure. So for stuff that is not pure, like BO files, sometimes people get...
That's not my major... if I can rant about something, in the case of Dune, that's not my major complaint. My major complaint is that I've read the documentation countless of times, and I still do not understand how to call Dune to produce this basic stuff. It's just a mystery where... You
just call Dune build and the target you want.
Yeah, but exactly. But the target, I don't know how to get the target. Like the question is like, where do I get the target? Where are the aliases defined? I have no idea. I just grab random Dune files.
With open books, or if you want, Pierre-Marie, we can improve the documentation.
I had the open something.io stuff. Yeah. Like every time I read it, like what the hell?
But actually, so Dune for testing is not great. At Enrico comment, the main advantage you get from Dune versus a custom program is that imagine you have a million tests, like in a code base, so maybe this is not applicable to Coq. The main advantage you get is you only run the tests that have that need rerunning when you do a pull request. So this is, for example, for the kind of code bases that Dune is used, which are in the 100 million lines of code or something like that. This is very important. So for example, I'm not sure for Coq, but actually this is the same case for Coq. So what Dune brings you versus a custom or unit, no, we have a unit, or there is all this testing framework, is imagine in Coq is less applicable because almost all the tests depend on Coq-C, right? So yeah, this is the main thing it brings to you.
Yeah, it's a bit late to make this remark, but I'm not sure. I mean, it seems you have to fight a bit Dune rather than take a lot of advantage.
So the reason I had to fight Dune a bit is because I tried to be faithful to how our test suite looks today. The way, the kind of actions that it does, I've tried to keep those. If I were writing a test suite for Coq from scratch using Dune, I would not do it this way.
Would be okay.
I would do it a completely different way that would work well.
It really depends. For example, if you have OCaml, Maxine is not his epithet because he's always saying about this. If you have, for example, unit test, in terms like typical unit test, for example, Dune is going to work very well because imagine you just change the pretyper, you only need to rerun the pretyper test. So this is actually this incrementality of running only the tests that are needed. This is good. So for as Ali says, for the way the test suite works, it's not so good because you gain like running code depth. well, already this is great. Like we can run CockTep easily here. You can that as a big game, but this is a bit independent. Other tool could do that too, of course. But then, of course, you manage all these. You can manage all these indeed, all these dependencies. Actually, this is a good thing. Okay, the file is here, but if you open the file, open the rule file.
The what?
The rules file. Open the rules file. On the other hand, is pretty easy to.
Which one?
The rules file. Yeah, the text with rules.
No, I mean, these are the tests.
No, the generated file.
Oh, okay.
So actually, a good thing in this sense is actually this is very easy to understand. Okay, but I don't know why I complain, but you see, basically, if you look, is an alias, standard dependencies, and an action. So on the other hand, there is little black magic here. It's like Bazel on other build systems. It's very easy to understand what's going on.
Actually, I prefer having a monolithic Dune file. My major problem is I have no idea how to crawl all the Dune files to find the list of things I can do. So like, I don't even know how to list the available aliases.
So on the side, and just from a Dune point of view, there will be completion added to Dune, maybe this version or next version, so 3.7 or 3.8, where you can just like tab and it'll tell you what kind of.
Maybe it's not a great idea with this kind of Dune file, but yeah.
But I mean, Dune, when Dune runs, the first thing it does is it checks all its files to see what it can do.
Yeah, that I gather, but the things like the fact that the data is spread all over the place is quite annoying to me. I know it's a design choice, but still.
Actually, yeah, in this Jean-Marie, actually, for example, that's the thing. This is a very good question. For example, like one of the reasons this is not, of course, like the scale Dune is used, this is nothing for Dune. Actually, well, though it's getting slower. Since Jeremy left the project, but no Genius Truth is porting the code base. They're trusting in something much larger than Coq. The problem is, for example, this is very interesting. For example, to generate all the aliases available, you have to run because take into account this is dynamic dependencies. This is very important. So actually, this kind of commands like generating the aliases is not so easy because it may involve arbitrary building.
So you mean that when I will do tab bash, you run?
Yes, that's a problem we were discussing there. Exactly. That's a big problem. Yeah, but this is essential because imagine, for example, imagine you vendor the Camel compiler. Okay, so sometimes you need to run a Camel tab, for example. So yes, this is the thing when you do tab. This was a big discussion, and this is what they don't have. It's because it's many things have been tried, so it's not an easy problem. For example, when you need to compute the targets, of course, to compute the targets, for example, in the case of generative files, you need to run rules. So it's easy, it just can be very expensive.
Yeah, I'm not complaining about the design choices of Dune. I'm complaining about the net result as.
No, certainly the interface, and Ali's been working very hard on a new interface for Dune. With Rudy, the interface is not good. This is clear for people. I mean, I understand it because I hack on it, but like Coq.
So, are we getting to a conclusion of this part?
So the conclusion that I want to get to is merge. So that we can, stop saying the test suite is broke.
Okay.
No, because the main thing is that people say the test suite is broken. It doesn't work the way I want it to. Now it does.
Yeah, what we can improve it. The merge actually. Are there known bugs that needs to be fixed before the
Not
merge?
at the moment.
I didn't check the pull test.
There was Emilio was suggesting that something should be done before the merge.
I want to do a bit of refactoring, but like 1 or 2 hours. I don't want to do very early.
So I'm not of the opinion this is a good idea.
Yeah,
so
you're
every
not
time
of
we
the
say a
opinion.
bit of refactoring, it turns out to be
Merge.
I think, folks, okay.
Yes, a few questions.
Put a new PR that reflects it.
Or put a deadline on your refactor.
Well, actually,
Tonight at 5.
No refactoring this afternoon.
The only thing that's asked for this one, I just want to
We're not
do
doing 2 things at a
documentation.
time.
well, if you want to take my advice, I would rather not have 2 pieces of code generating rules for Coxie because then you are gonna have a bit of pain to maintain that.
Yeah, only for a week until you merge your next PR.
We're talking about the
No.
300 lines of code there? Or something worse that you have hidden from our view?
So we have Coq rules. So there's 2 of these. This is my one.
There is 2 rules. This has to go away. I'm sorry. Well, this is my opinion. Of course, if you want to, this is my opinion, and I think this can go
So this
away
is
in a
how,
1 hour hacking.
Okay.
Up to you, Fox. If you want to put that, but then I think it's
You can do it tonight, but not this afternoon.
I will do it on Jody. Judy.
The thing, if it is an hour, it's also an hour after the merge. I really don't understand your complaint. It's only if you don't do it, if this is merged, then I understand your complaint. But if you want to do it, and you do it.
Well, it's an estimation. Okay, well, up to you. Up to you. Maybe if it's merged, then I move to other fields.
Exactly. Yeah.
Exactly. Yeah, but we could also have the situation where you promise to do it and you move to another thing, and we don't merge.
Well, we can say that we merge by the end of the week, whatever happens.
Yeah.
It's
We're
called
factoring
a
on
merge
that.
debate.
So we will merge it like it.
But you had questions in your review.
Also, there is this notion and another to do, but this up to you. But well, we will see. There is still some issues. But yeah, I think it's much better than what we have. Another thing is actually, I think this should be a bit more structured in the sense what is something which is called in this testing suite, what is called like a test package. But yeah, but this can happen later. This doesn't need to happen now.
Okay. So merge by the end of the week. We're factoring on it.
By the end of the week.
Who's assigned? Who's following it?
Gaetan is assigned or no? Or you reviewed, but you're not.
Do you think Gaetan, no?
Are we taking the English notion of the end of the week or the French one?
By Friday.
By Friday.
Of the work
that
week.
end of the week.
Work
week.
End of
So at the moment, Jim requested changes for the documentation, but that can be done in a later PR. Hopefully, I mean, I don't know, give me your opinion on the documentation today. It might read a little less technical than...
You wrote a lot of words, that's good for me.
Yeah.
In the...
For what concerns documentation, I'm a bit worried because
yes.
You also asked me to merge the switch to Dune for the Coq DPD graph.
No, but I retracted that ask. I said, don't do it. No, Carl wants to merge it, and I don't think it's a good idea.
Why? Well, maybe we can discuss that.
We can discuss that.
Yeah, we should go to lunch.
It's not the point here.
I guess between 2 and 3.
Because I've been working on this.
So, regarding documentation, if there is any concrete suggestions that from Jim that you want to act on, then do it before the merge, and anything else, leave it to other people to improve later.
Yeah, I'm okay.
Yeah, also I think if we start to use it, we will figure out that sometimes you don't know how to do something.
Yeah,
exactly.
so everyone,
what needs to use it.
Everyone can contribute to the documentation when they realize that something needs to be documented.
Exactly.
For the 2 and between 2 and 3, I guess we will have a free time to hack and talk to each other before we have the session with Benjamin, right?
There is 1 hour.
Why is it written?
Yeah.
If we start at 2.
Why is it written? It was written in session 2 to 5 for
design. But the thing by Benjamin starts at 3.
Okay.
So because they told
So we have 1 hour to just chat and.
So the real sessions will start back at 3.
Yeah.
Okay.